Thanks for inviting me along today. My name is John Staveley. I'm a .NET contractor based in Leeds area. So this is I think my 5th or maybe 6th talk at .NET North. So tonight I'll be talking about guaranteeing application of Azure security with DevSecOps. I chose DevSecOps because it's a really sexy term and you're guaranteed a great turnout, but I'll hopefully explain some of what that means going along. So DevSecOps, or the security aspects of DevOps, or how we implement security as part of our development lifecycle, and doing as much security as we can early on in the lifecycle. Excuse me, this is my daughter who I asked not to come in. Obviously, I asked her not to come in, so within 2 minutes she's knocking on the door. But there you go. So what we're trying to do is amplify as much security through the various stages of the development life cycle as we can, and amplifying the feedback of that security, so improving our security profile throughout the process. What we're trying to do is start with an enhanced security baseline, so working with secure by default, the best secure configuration we can have, and reproduce it. So everything we do is scripted, everything we do is on templates and Azure pipelines, so it's exactly the same security process each time we do a check-in and each time we do a new project. So some of the things that help us when we're doing this is lightweight threat modeling, so not a big bureaucratic process, but on to more of that later. How we can do security checks in the IDE, static analysis and all of the code, the platform, the components we're using, how security unit tests feedback security into our process, then doing dynamic analysis on our implemented code, our deployed assets in the cloud. So how we can test that using OWASP, ZAP, and security acceptance tests. All of the code is on GitHub, and the slides on SlideShare will be tweeted out after the session. I'm going to leave questions till afterwards because this is quite a long talk and I've been asked to compress it into an hour. So some of the aspects we're talking about I'll be going through quite briefly. So if you've got any questions, then reach out to me on Twitter or LinkedIn. So what do we do security? Well, GDPR says we have to, use developers have 48 hours to report a breach. Last year, there were hundreds of millions of pounds worth of liability associated with security incidents. Lots and lots of big name companies, pension funds, Facebook, Burger King fined, EasyJet was hacked 9 million records a few months ago. Security is really important and should be important to the organization as well. So how do we approach security? So DevSecOps is just DevOps with a bit of a focus on security. So I'm explaining how we put security in each of those phases as we go through the talk. DevOps is how we implement a fast flow of work from dev into operations. So we do a check-in, it gets committed, built, deployed, and then checked all the way through. And then amplifying those security feedback loops each stage through the unit tests, through what the tooling tells us, and then through into the cloud, what the cloud zone tools can tell us. And we're looking to improve our daily security work as much as possible. So more on that in a bit. And then we work with a secure by default code and platform. So part of the code that I've got on the GitHub, it's had lots of security checks done on it and on the platform as well. So if you work with that as a baseline, you get more secure by default than if you just do file new project, for instance. So what I mean by pull left is early in the development cycle. So a traditional waterfall approach, you do requirements analysis, design, coding, testing, hardening, and production. And we've moved on from waterfall, we're agile now, but if you think about it, a lot of security is still done in that way, where we do a number of sprints and then we do like the pen test at the end, and then we have to do the fixing of the pen test of all those bugs. So what we're trying to do with DevSecOps is trying to do more security in the requirements and the design and the coding and the testing and the hardening. You still do the pen test, but that just feeds back into all of those previous stages and tells you what checks you should have done, how your design approach should be different in future. The benefits of doing it secure by default means fewer security defects, less work on security, reduced average time to detect a security issue. If you're doing DevOps, then you can deploy security updates and security patches much quicker, and you're providing a moving target to hackers. So it's much more difficult for them to get a hook into your system. And of course, fixing a problem in production is 6 times more expensive than fixing it when you're designing it. So what we're going to secure tonight. So 4 years ago, I did a talk at .NET North on Security Essentials. So it's essentially the OWASP top 10 implemented against the file new project, MVC project. It's still there. It's still sort of best of class in terms of security. It covers SQL injection. It's got a very strong account management process, defeats account enumeration, brute force attacks, checks for pwned passwords against Troy Hunt system, hashes passwords and encrypts data using a strong algorithm. Lots and lots of security checks. It is a .NET program rather than the .NET Core. This talk is not about the fact it's .NET or .NET Core. It's about how we are doing, how we're assessing our security posture at each of the stages. But I had to use something and deploy something, so I said, well, I'm just going to use this project. So what it consists of, so you've got an app service, a key vault to hold your secrets, SQL Azure, binary blob storage for your binaries and blobs, and then I use Cloudflare as the firewall, a sort of best of class firewall. So you're talking to it, that talks to the outside world where either your happy customer or your nefarious actor is trying to attack your system. So the demo code's there. It's going to be tweeted out after the talk. Of course, we're doing infrastructure as code, so all of the platforms repeatable and automated using an ARM template. The Cloudflare setup, that's the firewall, and the WAF, web application firewall, is set up using PowerShell, just hooks into their API endpoints. So it ensures it forces TLS, HTTP2, enables the WAF, protects against denial of service, SQL injection, and many, many other types of attack. So one of the things we do in the application is we lock the app service down to Cloudflare, so the Cloudflare app service can only talk to Cloudflare, and nefarious actor can't bypass it. We use Azure Key Vault to protect secrets, because obviously we don't want to store secrets in our checked-in code. And then a virtual network secures all the different assets. They can only talk to each other within that virtual network. Within the other assets we deploy, we've got blob storage, so enforced encryption at rest and in transit. It's firewall to the virtual network. SQL, you've got transparent data encryption, vulnerability scans, and backups. Okay. So what that looks like when you deploy it into Azure is it essentially looks like this. There's application insights for logging, Key Vault, there's my app service and app service plan. Of course, we wanted to make that repeatable, so we use like this ARM template here. So here you get a sort of nice view of everything. So if you go to the website, for instance, there's a basically a JSON description of what that website should look at, how it should link into the server farm, SQL properties, all of these things that are switched on or off, the tracing and HTTP logging are enabled, which are common security things that are forgotten. So in terms of your Azure pipelines, you just deploy that using, that's the wrong one, using a section of code here. So we got Azure pipelines is a YAML description of your build process, and that will deploy your website with the parameters set here into Azure. So everything is repeatable. So why automate? Why do we have that build pipeline in Azure pipelines and the ARM template and the PowerShell? So what I find is really useful about it is that it's very easy to create new environments. So you need a QA environment or a UAT environment, or you need an environment that's just going to be for the pen test. You just run that script with a different set of parameters, all springs into existence, deploys the code onto it, run whatever tests you want against it. And then when you're finished with it, you can crash it down again afterwards and do that as many times as you want and reduce cost. Because it's repeatable, it's very easy to roll forward. So say you find a 0-day vulnerability on your website, one of the packages you're using, you can roll forward and fix that very quickly. What that means, though, is that the CI/CD pipeline is now your heart of security. Your Azure pipelines enforces the rules, it enforces the checks, the ARM template enforces certain assets that you're deploying into the cloud. But that's all checked into source control. So if anyone makes any changes to that, that's all logged and is audited. And then all those security rules are enforced each time you check in. Okay. So very quickly, I'm hoping you've seen an ARM template before. So this is my Security Essentials project. You see it's built in 2 stages. I can edit my Azure pipelines in the web as well as within Visual Studio. So this is exactly the same script. So here it says, well, use NuGet restore, for instance. So here I've got a variable section. So here I can set up my secrets. So there's my Cloudflare user service key. So I can't get at that encryption password. And all of those are injected into the pipeline when I build. So a lot of these security checks I do use extensions. So we use the marketplace to get that. So let's say that we want let's say we want the AZSK an extension called the AZSK security extension. The Secure DevOps Kit. So you just click on search it, get it for free, and then you click on it to then add it into your pipeline, and then so it says add it in there and download it. So then that's now available in the pipeline ARM template. So what do my Azure pipelines script do? So first of all, it does a NuGet restore, npm, build and package, runs a security unit tests, does code analysis for security vulnerabilities, then does component analysis in 2 different ways. It checks the platform. So because I'm using an ARM template, it compares the ARM template against known vulnerabilities to see if there's anything that I need to fix. Does an anti-malware scans. If by mistake I've checked in any malware into my source code, it scans for credentials, publishes the artifacts. So that's all fairly standard. Some of these are standard boilerplate. Once that stage is complete, so that only takes probably about 8 minutes to complete, then it runs acceptance tests. So here it sets up the paths, the app service, and then firewall, blob storage, SQL, that kind of thing. So then it deploys it into that PAS, and then we run the security acceptance test against it, and then does some dynamic analysis. So that's OWASP SAST. So each of these stages, we're checking security and giving fast feedback to the developer if there's any security issues to look at. So how are we going to pull that security left? That is as early as possible in the development life cycle. So this diagram I've taken from a book on DevSecOps, one of the best books I've read on the subject, which I'll be giving a link to at the end, which shows how we can pull in security checks at different stages. So here we say we need to change the code at the pre-commit stage. We can do these checks, threat modeling, IDE, continuous integration, acceptance test, and then deployment into production. Each of these stages, we're doing different kinds of security checks. And overall, what we're going to talk about today, talking about some lightweight threat modeling, what checks we can do in Visual Studio, some component analysis, static analysis, security tests, then in deployment stage, dynamic analysis, acceptance tests, and then production, getting feedback from the platform, doing automated security scans. So first off, we're going to talk about what happens at the pre-commit stage. And here you can consider the checks we can make in the IDE and threat modeling. So lightweight threat modeling. So there's this fantastic book by Adam Shoshak, which is about 500 pages, which you don't have to read because thankfully he's created this fantastic software product that encapsulates a load of threat modeling rules for Azure in the tool. He was the chief threat modeler for Microsoft. And it's all around this idea that if the code is the design, where and how do you catch security problems in the design? If you're introducing an asset into your system that you know nothing about, how do you know where the threats are and how to counter them? And how do we classify threats? So we use this STRIDE acronym. So spoofing, that's pretending to be someone or something you're not. So an example of that is cross-site request forgery, if you're familiar with that. Tampering, sniffing or changing something at rest and made in memory or transit. So an example of that would be SQL injection. Repudiation, doing something and then denying you did it. I.e., if you've got weak logging, then people can deny they were ever on the site. Information disclosure, giving information to an unauthorized person, such as man-in-the-middle attacks or showing you errors on screen. Denial of service, degrading or preventing access to a service by, for instance, locking out accounts if too many password failures. Elevation of privilege, doing something you're not authorized to do, such as indirect object reference, which is on the OWASP top 10. So we're going to be looking at the identifying threats using the Microsoft threat modeling tool with the Azure template. So it's got a couple of different templates. I'm using the Azure one because everything I do is deployed into Azure. Okay, so I'm doing threat modeling, when I'm introducing a new asset into my environment. And this is my environment. So here I've got my friendly user talking to a browser. The browser talks to the firewall, which then talks to the app service, and the app service talks to the blob storage, SQL database, and keyboard. So this uses the template, so the Azure template. So this knows all about the kind of things that Azure can do and the kind of mitigations you can do. So it shows a lot of useful information. So I get my assets from on here, so Azure Cosmos DB, drag them on. This took me about an hour to set up. It only took me an hour because I like all the lines neat. This is really a very quick process. So once I've got all of this set up, I can then go to the analysis view here. If you click on one of these, the threats is identified. For instance, this one here. An adversary can fingerprint an Azure Web Application API by leveraging server header information. So STRIDE category information disclosure. So it's saying here the possible mitigations for this are to remove standard server headers to avoid fingerprinting. So there you can go. There's a couple of links you can click on and it will tell you how to remove, what headers to remove, and then how to remove them. So I've classified this as justification. Server headers are removed by HTTP headers, which is a class in my application. So we've got a threat and a mitigation, and it's highlighted in the diagram. So between the client firewall and the app service. And I've understood what threat is and then mitigated against it. So here's another one. And obviously you can read confidential data due to weak connection string configuration, again between the app service and the SQL. So between the app service and the SQL database. Clients connecting to an Azure SQL database instance using connection string should be ensure encrypt equals true and trust equals false. And there's some more links you can click on, and I've justified it as mitigated. So that threat's mitigated in my system. So very practical, very advice, not bureaucratic, not involving lots of teams or reading a long book. Very, very straightforward to use. Now, let's say I'm engaged in CV-driven development and I'm a developer and I want to drag in Azure Redis cache here. Now, I know absolutely bug all about Azure Redis Cache, and certainly not about mitigating security threats against it. But if I put it into my diagram like that, then you'll see that at the bottom here, there's a whole new section of threats that I'm now susceptible to that I'm going to have to look at: elevation of privilege, information disclosure, spoofing, and then the mitigations. So, and links to how I can deal with those threats. So, very simple, very practical advice on how you can mitigate threats. Very powerful in my view. Okay, so the other thing you can do at the pre-commit stage is IDE checks. So there are some basic IDE checkers you can get from Visual Studio and other editors. And it can spot some basic security problems like SQL injection, weak cryptography. So a good one will have a good IDE integration, can also run on Azure Devops. So if the developer's a bit lazy about checking the rules, the CI/CD pipeline will defend you there. Allow you to build your own rules and have a low false positive rate. A lot of these, the IDE checks do have some false positives. But if you do have a problem, it would link to good code examples and tutorials so you can fix the problem, and also able to define exclusions. You're not permanently sifting the same ones you've already rejected as not being a threat. I would say IDE checks are the thin end of the wedge. They're not really very mature as a product. And a lot of the other stuff we'll be talking about tonight is a lot more powerful. So IDE checks I've looked at so far: DevSkim, you can find insecure hash encryption algorithms, insecure URLs, secure credentials and code. PIMA-Scan's got a free and pro version. You can check for secrets, compiler settings, and authentication settings. For your code, you need an account to run, and you check the SQL injection. And then there's a continuous delivery tools for Microsoft, for Visual Studio by Microsoft, which can do credential scanning locally, which is quite useful. So now we've done our design, we've checked in the code, we've got assets in the repo. Now we can do the continuous integration and build. So building the assets, I'm going to consider 3 things we can do here: static application security testing, component analysis, and security unit tests. So we're addressing each of those one at a time. So static application security testing, or SAST. There's a number of tools that could help you here. One I like to use is FXCOP. It's straightforward to use, and it's very easy to set up. But there are others like PIMA-Scan and Roslyn checks as well. SonarCloud can also check your code, which I describe as SonarCube as a service. And then the Microsoft Security Code Analysis does a number of tools which you can plug into your build pipeline, which are Credential Scanner, Roslyn Analyzers, and TSLM. And then finally, to check your platform, there's the Azure Security Kit ARM template checker. So first off, FXCOP. It checks code quality, design flaws, globalization rules, naming conventions, performance, maintainability, portability, reliability, and of course security, which is what we'll be focusing on. So in terms of the security rules, it can check catch insecure SQL, class design, XML external entities, attacks, anti-forgery tokens are missing, weak cryptography, deprecated security protocols, and lots more. It's very simple to set up. You just install the FXCOP analyzers package. So this isn't something that gets deployed into your production environment. It's set up as a NuGet dev dependency. And what you do is you grab the files. Well, I'll show you in a minute. One gotcha though is you need a version that matches your build date in Azure DevOps. Okay, so I've installed the package and I've grabbed this file out of the package. So this is the rule set. So for instance, for FXCOP. So here is a SQL injection rule, cross-site scripting vulnerabilities, LDAP injection, lots and lots of really useful stuff they can check your application for. And here, if I want, I can change this from a warning to an error, so that I can fail my build either locally or in continuous integration. I'll give you an example here. So in my user identity class, I use the SHR-256 managed class. Let's say I use something insecure, SHA-1. Now I've got some red squigglies. Let's say weak or broken hash algorithm. So if I build that, it'll give me a warning, or if I've set it to error, it'll error as well. But the point is, it's catching weak security early on in the development cycle rather than as a result of a pen test or getting hacked. So the second thing I'd like to look at is SonarCloud. So SonarCube as a service, sonarcloud.io, which is free for open source projects or for open repositories. So if you got a paying version, you can then have private projects in SonarCloud as well. Shows you what is wrong and how to put it right. It can pick up bugs, security vulnerabilities, invalid CSS, deprecated HTML, performance issues, code duplication, etc. But what we're interested in today is security. It can analyze where bugs are clustered. So if Bilbo, the new developer, is not very good, you can do analysis based on whether the bugs are related to their check-ins or whether they occur on a Friday afternoon. Yeah, you can cut the data however you want. You can fail the build if you encounter certain vulnerabilities. So it's pretty easy to start up Azure pipelines. Again, I've added in the SonarCloud add-in from the marketplace. And there's 3 steps. I got a project key from sonarcloud.io, and I set up my project name there. And then I run an analysis and publish the results to SonarCloud. Okay, so this is what it looks like. So I've run it. It's saying I've got 38 bugs, 1 security vulnerability, 87 security hotspots. Oh my goodness, I didn't realize my code was so awful. But you can do this on every check-in, and if you think that's a really serious problem, you can get it to fail the build as well. So let's just go and have a quick look at that one. Refactor this code to not perform redirects based on tainted user control data. Why is this an issue? Okay, so I've got a very thorough description there with some bad code and also some good code. If I click on it, I'll actually see my code. So it's saying on my login async function here, there's this variable called return URL passed into redirect to local, saying refactor this code to perform redirects not based. So it doesn't like that code, basically. It's saying this is an open redirect vulnerability and how to fix it. And if you click on that, it'll show you some compliant, non-compliant and compliant data. Okay, so next in terms of static checking, the Microsoft have come up with a number of tools that you can put into your pipeline. One of them is a credential scanner. There's also anti-malware, bin skim, TSLM, all these here, and you can break the build. So, oops. So the first up is credential scanner. So it's best practice not to check in any credentials or secrets into your source code. So you can pick out any credentials, secrets, certificates, and other sensitive content in your source code and your build output. It's got 25 different kinds of searches supporting 70+ file types. So if it's a secret or secret-like, then guaranteed it'll pick it up. So the raw output file it produces looks like this. So it says in web.live.config, found password, symmetric key, or storage credentials. So that's the raw output. It could also publish a nice looking report as well. And so also other checks it can do. So tslint. So this is just tslint as you could run it by command line anyway. And they've got it as a build step. So tslint can check for TypeScript code for readability, maintainability, and errors in functionality, and also some security type rules. So no eval, no ban terms, no string-based timeout, that kind of thing. Again, picking them up at design time and check-in time rather than when you're doing a pen test and you found a vulnerability. So it's got some Roslyn analyzers. So this requires some setup, and it's integrated with your code at build time. The NCSA produces a report to be used to break the builds required. So the thing I'd say about this is it's quite expensive if you're a small organization. It's $5,000 to $7,500, but it is per organization. So if you've got 200 projects, it's still the same price as if you've got 1,000 projects or one project. So the more you use it, the more you get out of it. So we've done a lot of code checking now, but we've got some deployed assets in the cloud. How do we know they're as secure as they possibly can be? So Microsoft came up with a lot of security best practice from their security experts and came up with the AZSK, the Azure Security Kit. Can run security checks against our deployed resource group, an ARM template, as I'll show you in a minute, an Azure subscription, and then also set up continuous assurance, monitoring, and telemetry. I've used the first two more than any of the others, so I can talk about those if you want to ask questions. It's constantly updated, so whenever you run it, you'll get the latest set of rules. And there's a link to description of what it's about. So first up, you can check the resource group and ARM template checks. So for an app service, for example, it will check that you're using HTTPS only. That's rather obvious. HTTP2, you've got RBAC configured, SSL bindings, WebSockets disabled, FTP disabled. A lot of things that are a best practice, secure by default. For blob storage, it checks your lockdown to a virtual network. It's got a secure access. CORS is not overly permissive. It's got firewall access, soft delete for availability in case of malicious deletion, that kind of thing. Right, so I run this PowerShell command here, the ARM template checker, and it checks the. Okay. What it's going to go away and do is check my ARM template, which I showed you earlier. So that sets up my blob storage, app service plan, that kind of thing, with this live set of parameters and this exclusion file that I've defined here. So it runs through all of that, and it said, well, I've got 4 failed high vulnerabilities and 1 medium one I need to check. So these are the rules it's checking here. And interestingly, it's not opened the file, which it usually does. So it produces a file that looks something like this. It looks better in Excel. It's basically a set of rules and the reasons it's failed. And this is actually the exclusion file. So this is the things I've judged not to be security issues, like using Azure AD. Okay, yes, I might use it, but there's lots of reasons why I wouldn't use it as well. Let's see if I can get that file up. Oh, here it is. Right, so here's the results. Okay, so it's a feature. It's related to SQL Server or an app service, and it's failed. It's high level severity, and it's checking for site config, site 8 enabled, which expecting to be true. So there is found a config setting that should have been set but has not been set. Interestingly, that has not appeared in my scan before. So when I last did this presentation a month and a half ago, that didn't show up, to just show how this is dynamically changing all the time with security best practice as it gets updated. So you can also do that against a deployed resource group. So if, for instance, you've got you're not fully Azure Pipelines ARM template deploying, and you've just got something that's you've set up manually in the cloud, you can run it against something, a resource group, and I produce a file in much the same way. So now we're going to look at software components. So components is things like binaries, NuGet packages, npm libraries, that kind of thing that you might use as part of the project. So you're using two libraries here, the OWASP Dependency Check and White Source Vault. Both OWASP Dependency Check, you can run it locally or as part of your build pipeline. White Source Vault is just the build pipeline. So further to that, you can also check for anti-malware. So even if I check all my NuGet packages and npm packages, a malicious developer, for instance, or a careless developer can check in some malware into the code, and that will pick it up. And also BinSkin, which looks at secure build settings. So first up, OWASP Dependency Check. This is free, and it checks for vulnerabilities from the National Vulnerability Database, or NIST. So you can check for cross-site request forgery, cross-site scripting, denial of service, remote code execution, buffer overflow, lots of things. It can generate false positives, so it needs a bit of manual checking and maybe an exclusion file. I'll be going into how you come up with that. Right, so here's one I did earlier. So it hasn't been run for a while, so it just runs as a batch file. It goes and downloads all the latest vulnerability databases, and then use each of its searches to find for vulnerabilities. So then it comes up with this, a very nice, attractive report. It says there is this package here. It's got a severity of medium and there's a high confidence it's been identified. So let's take one of these, for instance. So if you click through on that, it's saying that system.runtime.compilerservices.unsafe. It's used this evidence to capture that it's the right file. It doesn't use hashes because it exists in a world where people combine their own binaries, which will always be different depending on the computer it's on. So it uses other things like vendor information, product information to identify a package correctly. And then it's got a CPE code and a CVE code. So this is the published vulnerability. The user resource create function, the services module for Drupal uses the password of one creating user accounts. What this means is there was a vulnerability which used this library. However, this is only related to Drupal. So this is an example of where we've got, we need to suppress it because we're not running Drupal and we know that much. So there's this little snippet of XML you can take and it can copy into an exclusion file, which looks like this. So this can be run via command line or in the build server. So these are vulnerabilities I know about, and I've said they're not applicable to my system. Let's take another look at another one. Microsoft.NET Core.Analyzers. So A lot of evidence that it's got it right, so we're confident about that. It's got this published vulnerability. A remote code execution vulnerability exists in .NET software when the software fails to check the source markup of a file. Okay, so I don't know what I'm doing with this at the moment, so this might be something that I need to look at and take a view on as to whether I'm affected by it. If I'm affected by it, I need to think about what mitigations I can employ against this. Maybe it's updating the package. Maybe I don't get it to pass files. Maybe the firewall takes care of everything. But I need to think about this vulnerability and what action I'm going to take with it. Okay, so a variant on the theme, you can use this package called whitesoft. It shows NuGet package and npm package vulnerabilities, similar but not the same as the dependency checker, and also shows license risks and compliance. So like if you're using a package that has a GPL license, for instance, then all of your software suddenly becomes open source and you didn't really want it to. It's got free or paid versions. So the free version covers 6 languages. The 2 I'm interested in of that would be C# and JavaScript. And then the paid version's got 80 languages. So you you put it in as a build step in Azure Pipelines, and you get a report that looks like this. So medium vulnerability, jQuery.1.9.min. Yes, the data grid I use in my software is relying on this old version of jQuery. So I can choose to update the data grid or run on a different version of jQuery or something. I can think about the vulnerability and do whatever mitigations I need to. So more checking, there's the anti-malware scanner from the MSCA. That uses Windows Defender, so obviously you can't use that on a Linux build agent. And then bin skim. So this looks at if outdated compilers are used and ensures most secure compiler settings are used, and the binary is assigned with strong crypto. So I see this as being useful primarily if you're deploying to Windows, where a nefarious actor might substitute one of your DLLs with something else. But otherwise, yeah, this is bin skim as the open source project, so you can run it locally if you want. So first, in terms of feeding security information back, you can do all sorts of security unit testing. Just check that your hashing and encryption algorithm works reversibly. Check that your email templates that go out contain the phishing warning. You've got a secure account creation, password reset process, which is in the OWASP top 10, very often a very weak part of the security process. Organizations like Netflix, they hash important code. So like the auth components and the finance components. So if anyone decides they're going to change those, it emails security and lets them know that developers be making changes to it, so they can check that. Another thing you can do is check the correct authentication applied to controllers. So this is the kind of unit test that does reflection over your controller and checks that there's an authorized attribute assigned to it. So obviously if it gets mistakenly removed, it'll start failing the unit test. So here's another one that checks for an anti-forgery token. All HTTP state-changing controller actions should be decorated with validate anti-forgery token. So again, by reflection, and then checks each of the post but delete actions are checking for anti-forgery. So this is countering the CSRF attack. So we've checked in code, we've got built binaries. We then deploy it into an environment. And here we can start doing some dynamic scans of our environment and security acceptance tests. So in terms of the Security Essentials project, it uses a number of files to do this. It's got pre-deploys. This creates a set of minimum resources, Azure resources, sets up key vaults and secrets in that, and the Cloudflare DNS and WAF. Then I deploy the ARM template, and then the build source code on top of that. and then post-deploy locks down the site to Cloudflare IAPs, so no other one. You have to talk to it via the protection of Cloudflare. Locks the base BOS version of PAS. This came up in a security audit I had once where we said, well, we just rely on Azure to update everything. And he goes, well, how do you know they update things? So on each check-in, it logs the version of the OS in the PAS, so we can track over time that as Microsoft are doing their job and updating things. And then finally wakes up the site. There's another script that then configures the site for testing. So opens the SQL database firewall for acceptance tests. We can plug in values and set connection strings, snap settings, that kind of thing. So the first step in dynamic testing, we use something called OWASP. That I heard this described as a pen testing tool. I think it's a bit lighter than that. You know, this is definitely not something you'd replace a pen testing professional with, charges £800 a day, whatever insane amount they do. You know, this again is just another tool that provides security information, feeds it back to you in the earliest way possible, so you can either make mitigations or corrections. So you can check for HTTP headers, including content security policy, do fuzzing against the application, check for directory traversal vulnerabilities, can do port scanning, attack WebSockets, cross-site request forgeries, information disclosure, HSTS, not set, lots and lots of different things. So this happens, after, depends on deployed integration. So deployed all our assets now, and then we set up the OWASP penetration test. So this is pretty much lifted and dropped from the marketplace, because you can see that it's got this hideous bash script that I haven't got a clue what it does, but that comes from the marketplace. You don't really know what that does. It just converts the output of ZAP into a test file that Azure Devops can understand, and then publishes those results. So it's pretty easy to set up. It runs on, Ubuntu. So if you're using Windows build agents, you need a different build step with a different image. So this is what ZAP looks like. You have what's called a context. The context is where you teach ZAP how to interact with the application. So you're saying, well, I've got my site, which is at securityessentials.staveley.org. I'm only considering those because there's various links off to other things. I don't want to go and attack those. I'm particularly not going to attack any of these. My website is built on this technology, so it's built on SQL Server, so don't bother checking for vulnerabilities related to IDE DB2, for instance. I teach it how to log in. So this is the target login page. This is what the post data looks like to log in. This is so that ZAP can then progress beyond the login page into the deeper parts of your application. I set up with these two different users, an admin user and a normal user, and this is how it does session management. So having got the context set up, again, that's part of the GitHub source control, and they can go and attack it. So first off, it will spider website. That means it'll go in at that entry point there, and then click through all of the links to find out what your website looks like. And then it will go start doing all of its different attacks, looking for NoSQL vulnerabilities, cross-site request forgery vulnerabilities. So here's one I did earlier. This is the report it comes out with, a ZAP scanning report. So it's got 0 high-level vulnerabilities, 5 medium, and 7 low. So it's saying that Cloudflare is being a bit naughty. It's given me a proxy disclosure vulnerability, so maybe there's some settings in Cloudflare I can use to switch that off. As a content security policy scanner, I'm using style source unsafe inline. Yes, that's the data grid that I use in the software. I really need to find a data grid component that doesn't use unsafe inline to make my application more secure. Script source unsafe inline again. Cookie without same site vulnerability. So that's the AR affinity cookie, so I can switch that off if I'm not using it. And the cookies need to be sent with secure flag. So that's something that's quite recent and a bit. Well, that can be that can be set up if I was using it, SSL. So again, lots and lots of useful security information that you can act on. So as part of the Security Essentials project, I've got some examples of security acceptance tests that you can do. So you can validate the anti-throttling works. So that's this one here. So I log into a website, I put in a duff password, I log in, put in another duff password, I log in, do another duff password. So within 60 seconds, if I do that, it'll show this this message here, which is designed to slow down attackers. You've requested this resource too many times in the last 60 seconds. So if I do a post against the login page more than 4 times in 60 seconds, then I'll get kicked back. So that's a test that's designed to show that that's functioning correctly. We want to make sure that the correct HTTP headers are returned, so we're not doing information disclosure, and the content security policy is set correctly. The account process is enforced. The content security policy and certificate policy violations are logged. So if there's violations to that, then you can set something called a report URI, which then does a post to your application or another URI that stores the information about the attack and where the attack took place. So we check that Troy Hunt's paid passwords, show a warning, and then that works in the solution and in Azure deployments, Azure pipelines. So I won't show you there. You can just assume that the test will pass. Okay, so we've done our dynamic scan. We've got the feedback from that, and our acceptance tests are now passing. We're getting the feedback from production. So this, in terms of what you want in production, you want your system available, so you need to monitor it. So, for instance, denial of service gets reported as soon as possible, and you do continuous vulnerability scans against your deployed assets. So as part of the ARM template, we set up availability monitoring, so it pings the website from 2 different locations, and you get an email that says whether it's gone down if it fails 3 minutes continuously. Interestingly, this Azure is not the problem here. It's Cloudflare. Cloudflare has occasionally gone down. That causes sometimes trigger this. And then in Azure, you get the security center. So it's a center for security alerts and recommendations for all Azure resources and subscription. So what can this help you do? There's crossover with what we've done before. So for instance, on blob storage, it ensures you've got transparent data encryption, auditing set correctly, diagnostics and logs on your key vault, on your app service, any secure asset your asset accessing is logged. You don't have an overly permissive cause setting, encrypt data in transit using HTTPS. You've got denial of service protection enabled, 2-factor authentication enabled on your subscription, for instance, and storage access to the firewall. So there's stuff that's similar to what we've seen before, but in terms of a Venn diagram, there's always something that's a bit different. If your world is VMs, then there's an agent or several agents that I've just recently done this that can be installed on your VMs that do security monitoring on those VMs, and all of that information gets fed back into the security center. So what it's saying here is I've got 3 high severity alerts, 1 medium and 1 low. So if I click into there, it'll give me a readout of all the things I need to remediate vulnerabilities. So there's a vulnerability assessment on my SQL database. So that is an example of something that's not found anywhere else in my build pipeline, but it's feeding security information back into my build process. So I'm more and more secure over time. And it gives you a score if you're interested in the scores. So in terms of it does database vulnerability scans, they do it every week, check the new sensitive information you're deploying into SQL Azure, and then sent via email. It can provide checks on sensitive data, correct setting of database owners, the firewalls set correctly, guest use disabled, transparent data encryption is enabled, and yeah, lots of other things. So that completes a lot of what we're talking about today. Some things I've not talked about is how you secure the Azure portal. So obviously, if you can bypass the ARM template, then that's a bad thing. So you should look to set up two-factor authentication on the portal and on DevOps as well. Then within that, you need to secure who can edit the CI/CD pipeline and disable checks and all that, because that's your backbone of security. If developers bypassing that process, then you're not secure at all. And one of the most powerful methods of finding security vulnerabilities is code reviews. So getting your other developers in your team to look at your code. That's something we've not covered here. So I'd say pen tests, they still happen. They're still very waterfally, but what we're doing is building in the process as early as possible in design, in the IDE checks, in the component analysis and fact checking. So any results you get from the pen tests should trigger the question to you, how can we improve our process? Where best in that process, in our development lifecycle, can we improve the security checking, and what went wrong since vulnerability got through? So in summary, security defaults mean security defects. So I provide a secure project that you can use as a baseline if you want, and a secure Azure build pipeline. Automated deployments mean security defects can be fixed faster. You can roll forward quickly when you find a vulnerability. In terms of the tooling, we've looked at lightweight threat modeling, providing practical information around Azure resources that you can use to counter threats. IDE checks, thin end of the wedge, but still providing user information. With pull left security, identifies security defects earlier. I think with all of these things, there is always crossover, but there is definitely no magic bullet with these. As I put more and more of these checks into the system, I was finding out more and more about the security profile of the application I was running. So someone said to me, oh, well, I just prefer to do it all in the IDE. And I said to him, well, you're going to see less than 50% of the picture if you only consider tools that run in the IDE. You need to think more broadly than that. In terms of CI pipeline, you need to do static checking. A number of tools you can do that with are FXCOP, Sonar Cloud, platform checking with AZSK, and then looking for credentials with the NCSA components and TSLint JavaScript. Then you can check your components for the OWASP dependency check, white source bolt, and then NCSA bin skim. Once you're deployed, looking for security defects using OWASP SAP and checking your security profiles good using acceptance tests. Then once you're in production, checking your system is available, an out of service attack, and using Azure Security Center to feedback security information to you, the developer. So there's some resources that will help you on your way. The method I take is this O'Reilly book. It's where the diagram comes from. This is the best resource I found on what he calls DevOps. I call it DevSecOps, but I wouldn't want to call it. This is a really excellent resource on how to build in security into your pipeline. There's a couple of full-site courses on some of the tools we covered today, securing application lifecycle and Azure Secure Compliant Development Process. The Azure Security Best Practices is a very readable document that covers a broad brush of some of the things that the tools will tell you and how they'll implement. So that's worth reading. And the Unicorn project's just come out, which has a really good secure security case study on how not to do security, obviously, and how to do DevOps really well. It's an excellent read, the kind of thing you can read on holiday, get it for Christmas. Let's go.